Good morning, everyone. Okay, today, finally, we're going to start with the programming. And the first programming language that we're going to review is C. Programming with C. The reason because we're going to review C, remember, is we want to review the imperative or procedural paradigm. Our goal for this class is not for you to be experts in C. It's not the goal. It's not like you're going to go out from this class ready to go to a program job interview as a C programmers. No, we're going to review the big picture of the language because we need to understand the imperative paradigm, the procedural paradigm, and to be able to explain why or how that paradigm is different from the other that you already know, the object-oriented paradigm. Good? So for that, the imperative paradigm, the key idea is we do not have classes, we do not have objects. The only thing that we have is methods, and we're going to call those methods functions. Key idea, methods, functions. The same thing, but in different paradigms. For this one, we have functions, and the functions are going to have, obviously, instructions and variables. And you're going to have global variables. Your programs in the imperative paradigms is going to be like variables and functions, a collection of them, in particular, global variables and functions. All the functions can use the variables, just like when you have this in a class. The only thing that is happening is there is no class enclosing this. Inside of your functions, as usual, like in the Java paradigm, you're going to have inside more variables and instructions. And the instructions are going to include all the algorithmic instructions that you know. Control structures, conditions, loops, and obviously instructions for printing something or asking something for the user. We need to learn this, obviously, but maybe the most important thing is we need to review the grammar in order to be able to create the key elements. Maybe the declaration of variables is going to be different, or maybe the declaration of functions, or something with the instructions, or something with the variables. We review that, we compare with Java, and then conclusions. And we can move forward to the next programming language, to the next paradigm. Good? So what we are going to review in particular is the most important things that you already know about the imperative paradigm. And you already know because those are the same that in the object-oriented paradigm. You already know this because you know Java. In C, variables are almost the same that in Java. You are going to notice. In C, declaration of functions, methods, the grammar is almost the same that in Java. The loop statements, good news, for, while, and do while, they are the same in C than the rules that you know from Java. And the conditional statements, if, switch, and even the question mark operator also exist in C. So these four things, you already know them. Now, why? Why you already know them? Well, very easy. Even though you learn Java, and Java is a language from the 90s. Well, that language is a child, if you want to solve this like inheritance, from another language from the 80s, C++, that, by the way, we're going to review that one later. And that one is a child of another one from the 70s. That is the one that we're going to review, C. You're going to notice that in these three languages, variables, function declaration, loops, and conditional statements, they are almost the same. So what you learn in Java about this is going to be the same when we review C++. It's the same now that we are reviewing C. That is good news. You basically learn three programming languages in one. Now, which things are going to be new? Well, new things. Arrays. I am sure that you learn arrays in Java. You are going to notice differences from what you do in Java with arrays and what we are going to be doing here, both with C and with C++. You're going to notice that arrays in C and C++ are a little bit more connected with the hardware thing than with this abstract way of thinking in Java. Because remember, in Java, arrays are almost the same structure, the same keywords, and the same programming that you follow with objects. Objects and arrays use the new thing, right? The keyword. Here, things are going to be a little bit different. We need to review that. Second, structs. A struct is the closest thing that we have in C to a class. Help me, what is a class? Everyone is sleepy, okay. A class is a collection of variables and methods. The closest thing to a class that we're going to have in C is a collection of variables. A collection of variables is going to be a struct. What is the difference between the struct and the array? The array is a collection of variables, all the variables the same type. So you can have an array of 5 integers. You have 5, but the 5 are integers. In a struct, you can have a collection of variables, maybe one integer, another one a floating point number, another one the name for someone. You can have a struct to store, for instance, a student information, the name, the grades, and so on. It's not a class because it's not going to have methods inside. It's just a collection of variables, a collection of attributes. It's going to be a struct. Don't worry, we're going to review examples. We're going to talk more about it, but that is going to be the second thing that is going to be new compared with your knowledge of Java. The last one, and maybe the most important, is pointers. This one is probably the most important topic that we're going to be covering with C, and probably one of the most important topics in the full semester. A lot of questions in your exam regarding pointers. Very important that you understand pointers. We're going to work almost for 1 week with that. Pointers. Help me. Do you remember what is a pointer? Or maybe you remember the other name. What is a reference? We talked about them some lectures ago when we talk about memory management. What is a pointer? Something that points to something, right? Yes. The reference or the pointer, this idea of pointing to something or be a reference to something, is very fancy idea, But the truth is, a pointer is a variable. It's a variable. It's a variable that stores information. Well, in particular, information can be a value or an address. A pointer is a variable. It's a variable that stores the address of another variable. A variable that stores the address of another variable. And that is the idea of pointing to something. Because I have the address, I have this ability to tell you where in the memory that something is. So I am pointing to that, a pointer. Or I have a reference to that. I have the address. So a variable that stores an address, that is the definition for pointer. Obviously, we're going to work with this. We're going to review several examples. 1 week. 3 new topics and something that you already know put together. And that is what we need to learn about C. Now, again, the most important thing that you need to remember is no classes. So the first thing that I need to ask you is, we're going to start using a new programming language. The first thing that you need to do is to forget about class, about public, private, protected, obviously extends and implements. All of that is going to exist here in the 90s. We are here in the 70s. All these things do not exist yet. So the first thing that is going to happen is you do not have a class. The second thing that is going to happen is your methods do not need to be public or private or whatever anymore. You are going to notice what happened with main. There is no public keyword at the beginning, just because all of that is related with this idea of classes and the access to the class, like public, private, protected, and obviously no inheritance. Those is connected with classes. Don't worry, we're going to start talking about this again when we move from C to C++. Because C++ is object-oriented, just like Java. But that is going to be in 2 weeks. So far, the next 2 weeks, maybe 3, what we're going to be reviewing is these topics. Today, our lecture, getting started with C. Today, we do our first program in C. Next lecture, I am going to talk about data. I am going to talk about the primitive data. And we're going to compare that primitive data with Java. In particular, the most important thing, what happened with the strings. Because right now, the most important thing that I mentioned is there is no classes. And strings in Java, they were classes. So what is going to happen with the idea of storing the name of someone? If I usually use a string to store a name, well, we need to talk about it next lecture, data. After that, we talk about pointers, data, variables that store addresses. And here we need to play with this. Why is it important to have variables that store addresses? What can I do with them? And how they are connected with something very, very important. There is a connection between arrays and pointers, and we need to talk about it. If you remember, when we review memory, I talk about arrays in Java. And if you remember, every single time that we have an array, we have a reference. Now in C, every single time that we create an array, we're going to have a pointer. And there are going to be a lot of consequences for that. And yes, the char array is going to be the replacement for the strings, but I would mention the arrays are pointers. So pointers, arrays, and strings is going to be our first example of how to use these things in C. Again, 1 or 2 weeks, I put this in red because, again, it's the most important topic. This is one lecture that you need to review, to be present, ask questions, or watch the video later, whatever. But this is the key lecture before your midterm. Now, after that, that is maybe the hardest part. We need to talk about the structs, as I mentioned before, and other topics related with the structs. This is the key. Remember, struct, this collection of variables that is going to be the beginning for what later is going to be classes in C++ and obviously classes in Java. So structs, and at the end, just to close, we're going to review parameters with functions, obviously. And to be more specific, we're going to talk about using pointers as parameters, because parameters is something that you already know. You reviewed that in 110. What I need to talk about is what happened when we use parameters, and in particular, we want to apply the new thing that we learned, like pointers as parameters. Moreover, if I want to send arrays as parameters, and we're going to play with this a lot. These are our next 5 or 6 lectures, so our next 2 to 3 weeks, programming with C. Good? Moving forward, getting started. The first thing, easy. You need a compiler. Number 1, C is a programming language that works with a compiler. We do not have an interpreter. Remember, we reviewed that. We review which programming languages only have a virtual machine interpreter, which programming languages only have a compiler, and which programming languages have both. I am going to use C and C++ as examples of programming languages that use only the compiler. I am not going to ask you to work with the .NET platform. I am not going to ask you to work with Visual Studio, we mentioned before. We're going to be working with C++ in the global way. They only need a compiler. Obviously, you can use any compiler available. I mentioned this, that is online, so you can do your homework even in your cell phone, connecting to that web page. Obviously, you can install Visual Studio, a very fancy IDE, and there are a lot of others that maybe you can use or you are already using. Eclipse, IntelliJ have the C-Lion version, that is Java, C++. If you are a Mac user, you can use Xcode, and the list can continue. NetBeans have also a C plugin. Any IDE that you want to use, good to go. Or if you do not want to install anything, go for the online. Anything. We are not going to use any fancy library. We're not going to use any fancy functionality of any IDE. We are just going to learn the language. Well, IntelliJ is for Java. If you want to use the C, C++, if I remember correctly, the name is C-Lion, something like that. It's the same company, the same group. They put different names for the different languages. You can explore the web page. That's it. Now, in the textbook for C, basically is the chapter 2. Particularly, if you have the new one, these are the sections that we are covering. And this is something that we are not going to review. How to work with files, the recursion, the 2.7 in the book, too much detail. If you want to read something, maybe those ones, not all of this. But again, remember that I mentioned this. It's not mandatory to read the book. This is the material that I am going to be covering during the lectures. If you follow the lectures, check the slides, watch the videos, you are fine. But if you want to read your textbook, if you have a textbook, this is what we're going to be reviewing. Moreover, a good book of C, if you are particularly interested in the language, because C is something that you're going to continue using in other classes. Most probably if you're working in an area that is connected with embedded or with hardware, this is probably the book that you need to review. It's a small one, really, but it's the book that talk about the language, and the author of the book is the same that create the language. So the author of the book, the author of the language, probably if you are particularly interested in C, that is the book that you can read. I am giving you a link. The first edition, very old edition, is available online, but obviously you can get a new one or a printed version, a little bit better than the one that is here in PDF, but you can take a look. There are a lot of tutorials online. I am sure that you can search for one. This is just one PDF with some examples that, in general, my intention sharing this is if you can open the tutorial, read the source code, and you're able to understand the source code, we are moving forward. Because that means that what you are learning during the lectures, all the things that we're reviewing, when you go and read source code in C, makes sense. That should be the goal. Yeah. Okay, so source code, examples, the book for C, because the authors, and the reference in your textbook, if you have it and you want to read it. Moving forward, step number 1, the anatomy of a program. What are you going to put in the compiler? How a program in C looks like? Well, 1, you're going to have, just like in Java, libraries. Tell me, which is the keyword that you use in Java to include a library in your program? Libraries in Java, a keyword, import, thank you. So, lesson number 1, the equivalent of import in Java, moving to C, is something called include. Include with a sharp at the beginning. Sharp include is the equivalent to import. When you read this, you know that you are importing a library. Now, in the next example, when you read or when you see something like this, that is about libraries. Step number 1. Step number 2, you can have global variables, you can have local variables, you can have functions. All of them are going to be inside of a file without any class. Good news, data types, integers in Java, floating point numbers in Java, chars in Java, 1, 2, 3, 4. Those 4 data types that you know from Java, they exist in C. Int, float, double, char. And I can add void. If you read any of those 5 words, they mean the same in Java and in C. And by the way, they are going to exist in C++ also. Right now, I didn't put here byte, short, long. I didn't put here Boolean. And obviously, I didn't put there string. So int, float, double, char, and void, those words mean the same, almost the same in C. they are going to be in our program. And I am mentioning these ones because variables and functions. Now, help me. Every single program in Java should have a function with a particular name. The only function that the computer executes, that function should have which name? One function mandatory in any program in Java, main. Thank you. Main. Any program in Java have a main? Any program in C and C++ also mandatory have a main. Same rule. Main libraries import now is going to be include, and these data types the same Java, C, and C++. Okay, your first example. Line 1 to 22. If I ask you to explain me what is happening there, when you read a program like this, can you imagine what is happening in the line 1 to 3? One, two, three. What is this? Moreover, line 10, what is this? The comments in Java, C, and C++ are going to be the same. You already know how to put a comment in Java, in C, and in C++, as you can see in this example. You can have comments in one line, and you can have comments in several lines in the same way in Java, C, and C++. So, yeah, 1, 2, and 3 is a multi-line comment. Line 10 is a single line comment. Easy. What do you think about 5 and 6? Include, import. Those two are importing libraries or including libraries, whatever word you want to use. The name of the library. In Java, you put this something dot something dot something dot something. Very long names for the libraries. In C and C++, the libraries have one name. By the way, the name is the name of a file. And as any other file, the files have an extension. The extension for the files that store libraries in C and C++ is .h. So stdio.h is a library. That library lives in a file. The file, if you search in your computer, is a file stdio.h. Literally, you are including the library, you are including the file that have the library. Similar idea with math.h. It's a library, it's in a file, the file is math.h. I am going to talk about the return in the line 21. Don't worry, moving forward. So libraries, one name, the extension .h. Now, one important thing. In C, C++, the libraries are going to have the char include, and the name of the library is going to be between the angular brackets or between quotation marks. What is the difference? If you have a library and the library is between angular brackets, that is a library from the system. That is a library that comes with the language. That is a library that is included in any compiler for that particular language. If you have a library between quotation marks, That could be a library from some package, some source code, some software that maybe you get from the internet, or maybe you are creating. The libraries between quotation marks are not part of the system libraries. So far, we're going to start working with the libraries in the system. So you're going to notice the Angular brackets. In some point, we're going to create our own libraries. And when we create our own libraries, those are going to be with the include, with the name, with the extension H, but we're going to include them in quotation marks, not in Angular brackets. You are going to notice that in some point. Anyway, Angular brackets, the name of the library. Math.h, that is the equivalent of the math class in Java. Anything that you need to work with mathematical functions, trigonometry, and square roots, things like that, is going to be in that library, just like in Java. stdio. Any idea about the meaning of that library? stdio. 2 words. std, standard, thank you. EO, input, output. Standard input, output. Yeah, the instruction to send something to the screen, that instruction is going to be in this library because the screen is the standard output. The instruction to read something from the keyboard, that is the standard input. The instruction is going to be in that library. Usually, any single program that you do with C, you are going to find yourselves using this library. Because think about it. It's very common that in a program, you want to put something on the screen, or maybe you want to read something from the keyboard. At least I am sure that printing something on the screen is something that you want to do, just to be sure that your program is working. And in order to print something on the screen, you need the instruction to print something on the screen. And that instruction is on this library, stdio.h. So libraries, line 5 and 6. Moving forward, a variable declaration, the type, int, the name, foo, equal 0. Global or local? Global. Why? It's not inside of any method. We haven't created any method, so it's not inside of a method, it's global. By the way, there is no class, right? Keyword class, nothing. Use the libraries, and immediately we start with the program. In this case, immediately after the libraries, we start with the global variables. Foo is a global variable because it's not inside of a function, global one. Important thing, do you remember what happened in Java when you create a variable x without any initial value? What happened in Java if I have a variable x and then I do a system out print ln x? What is going to be printed if I never put a value in the variable? Integer. It's going to be null for an object, for the integer 0. Thank you. Yeah. In Java. You know what happened? In Java, you have the garbage collector. In Java, you have this interpreter. One of the things that the interpreter do for you is to clean the memory. Clean the memory. Yes, you have the RAM memory in your computer, and then you ask for a variable x, and then this is your variable x, and let's clean everything. Cleaning means all the bits there, we put off, like turn on, off the light. So the value in the variable is 0 because the virtual machine cleaned the space for you. You do not have a virtual machine in C. In C and C++, if you create a variable And after you create the variable, you print the value of the variable. It's not going to print 0. What is going to print? A random value. A random value, yes. The garbage inside of the space in the memory. Garbage, yes. I mean, the last person that used this space, the last thing here, 1, 0, 1, 0, 1, 1, any combinations of 1 and zeros in that space, no one cleaned that. When you ask for a variable, this is your space, and inside you have the garbage that the previous one left there. Think about arriving to your classroom and maybe your desktop, your desk is clean, but maybe you're going to have there the coffee of someone else just because that someone else didn't clean. And because you do not have this virtual machine, I mean, this person that cleaned the classroom before you arrive, there is going to be someone there. It's not going to be 0. It's going to be something. Your responsibility as a developer for C++, if you want to have a 0 as initial value for the variable, mandatory, you need to put that 0 there. You do not do this in Java because by default, you know that the 0 is going to be there. In C, you need to do this. If you do not do this, the TA run your program is going to have some values. I run your program, it's going to have some values. You run your program in your computer. And if you run your program 3 times, you're going to have 3 different values each time. One different. Anyway, variables. No initial values, something important to remember. Next, the comment that we already reviewed. 11 to 13. What is happening there? That one is a method. No, it's a function. It's a function. Remember, no public, no private, no protected. That do not exist. The static do not exist. All that is connected with object-oriented. The only thing that I need in order to create a function is the type, the return type. If you put void, the function return nothing, but here you put whatever the function is going to return. In this example, this function return an integer. As you know, I need to use the keyword return. By the way, return is the same in C, C++, and Java. This function is going to return always the 5 and it's an integer. The next thing, the name for the function, parentheses, empty if you do not have parameters, curly brackets open, curly bracket close. The first time that we use curly brackets for the functions, again, there is no class, therefore there is no curly bracket enclosing everything like in Java. Function 1. And you can create as many functions as you want, just like in Java, but mandatory. Your program should have one with the name main. All this is the main. Now, for the main, do you remember in Java, public, static, void? We do not need the public and the static. We can use the void. We can have void main. In C and C++ also, we can have int main. The name for the method is main. And we can choose between 2 options. We can have the main returning nothing, void, or we can have the main returning something, an integer. 2 options. Now, why we want to have a main that returns something? Well, who is going to call the main? The computer. More specifically, the operating system in the computer. Remember, the operating system is the one controlling what is happening with the hardware. Windows, Mac, you have the operating system controlling everything. You can have your program returning something to the operating system. That something is an integer value. Integer value, usually you are going to return a 0 to tell the operating system that everything finished without a problem. That the operating system asks you as a program to run, you did your job, and at the end you finish and everything fine. Nothing go bad. I return a 0, like I am done, see you, everything is fine. Or I can return numbers, and those numbers are error codes. Error codes, a number that represents something that failed with me, and I need to tell the operating system 9. 9 means I was using some memory, and in the memory that I used, I was not able to release that memory. I didn't clean what I used in the RAM because I was not able to do it. There was some error because of the program or because of the computer, whatever, an error. Operating system, I am done, bye, but I let a problem in the memory. Or something else, again, 9, 5, 2, 1, errors. We're going to review some of those, but the most important thing right now is 0 if you want to tell the operating system everything is fine. Obviously, you can use void. Void do not return anything. So it's like you are not telling nothing to the operating system, which means you run, and whether or not you cause some kind of problem in the computer, you are not telling anything. Int or void, your two options. Moreover, after the name, you remember that in Java you have this string, square bracket, args. You have something inside. We're going to review in C that you have two options. Option number 1, you can have something inside. You can have parameters for the main, but also if you are not going to use those parameters, like I am sure in most of your programs in Java, you never use the parameters, but still you need to put the string, square bracket, args. In C and C++, if you do not need the parameters, you do not put the parameters. Use the parentheses empty. So main, int, or void for reporting errors, with or without parameters, if you need it or not. In my example, just to change a little bit your impression of programming, I am doing this int, and therefore I am returning a 0. As I mentioned before, everything goes well, no errors, no problem. I always return the 0. I can change this to void, work in the same way. Remove the line 21, put void here, it's the same program. The parameters for the main, I am not using any parameter for main. I am not using the arguments, parentheses empty. Open and close parentheses, that's it. Inside of the main, open curly bracket, closing curly bracket. That is my main method. My program, when I run the program, the execution of the program is going to start in the line 16, right? Because always your program starts with main. Not with my function, not with the global variables, with the main. And in particular, the first line of main, line 16, the program starts the execution there. What is happening in the program? New instructions here. Can you tell me what is happening with the line 16 and 17? Two instructions inside of main, what those instructions are doing? Printf is the equivalent to the instruction in Java. Printf, print function, is the equivalent to system out print, to be more specific. System out print, now it uses printf. Printf, and as you can expect, is a function, parentheses, inside the parameter, what do you want to print? In this case, hello world. And that is going to be printed on the screen, just like that. Next one, do you remember that \n? What I am printing in the line 17, print, quotation mark, \n, quotation marks, and enter. Yes, correct. Do you remember these special characters, \n, \t, \b from Java? They are the same in C, C++, and Java, the escape characters. Thank you. Yeah, they are the same. So if you want to print and enter, you can do something like this. And I am sure that you are wondering, can you print those two in one line? Like, can you print hello world and the enter together? And my answer is yes, of course, you can do it. You can print f, parentheses, quotation, hello world, \n, and then close the quotations. Why are you using two lines? Just for the example, two prints. One print without the enter at the end. The second one is use the enter, but you can put more things. Printf. Okay. Next. What is happening in the line 18? Several different things. Number one, I have a local variable. Local variable, integer. The name, x, is local because it's inside of the method. Moreover, which is going to be the value for the variable x? Hopefully you agree with me that it's going to be 5. How do you know that it's going to be 5? Because I am storing in x this. And from your classes in Java, you remember that what I am doing there is calling a method. And that is the method that is in the lines 11 to 13. And that method is going to return 5. Therefore, that 5 is the one that I am going to store in the variable x. Line 18, create a local variable, and that local variable is going to store the value 5. Therefore, when you move down and you do this foo global variable equal to x, 5 plus 1, foo is going to be equal to 6, right? Moreover, here, I am using the equal, I am using the plus. What is the plus in Java? Have a name, right? It's an operator. Do you remember that you have 3 types of operators in Java? 3 categories of operators? Which category is the plus? Is operator, arithmetic, thank you. Arithmetic, which is the other category? We have arithmetic operators, we have logic operators, and we have, okay, bitwise, we are not going to work with those. You are going to review that with the hardware. The other category, the Boolean ones, yes, relational, thank you. The Boolean ones and or not is what we call here the logical ones, and the relational ones, you know, the greater than, lower than, equal, different, and so on. So these are my 3 categories. Arithmetic operators in Java. Do you remember the plot, right? which are the other operators in Java that are arithmetic besides the plus? I am sure that the minus, multiplication maybe, division, and do you remember that guy, right? The percentage. It's not percentage, the model. Good news. The same arithmetic operators that you have in Java, they are arithmetic operators in C and C++. You already know the arithmetic operators for this language. Moreover, the logical and, or, not, hopefully you remember the symbols. 2 ampersands, 2 bars, and the exclamation symbol, and, not, and, or, and not. The logical operators in Java, they are the same in C and C++ also. So you know the logical operators for C. And finally, the relational ones, equal, different, greater, lower, and so on, all of that, they are also the same in Java, C, and C++. So you know the operators. You understand this line is an addition. Moreover, you know the priority of the operators. They have the same priority in the 3 languages. Great. Now, the only thing crazy, or at least the first crazy thing, did you notice this percentage there? Let's see. I am not sure if you have the opportunity in Java to review system out printf. This one exists in Java with all this name, and that is the exact equivalent to printf. If you review this in Java, if you have the time to review that one, I am sure you understand what is happening with the printf that I showed you in the previous example. But if you didn't work with this one, don't worry. Let me explain. What happened in Java when you have a system out print and a variable x, and you want to print like hello is a string, and also you want to print the variable. I am sure that you remember lines like that. You can have a string, and then you can do this addition, and you can add anything like the integer. And what is going to happen is that basically the print is going to print both things. The string and the value of the variable is going to be transformed to string, and then it's going to be sent to the screen. So you're going to be able to have both, right? Moreover, in Java, if you want to print only the variable, you can use print, and you can use the name of the variable, and the variable is going to be transformed to a string, and the string is going to be sent to the screen, and that's it. These are the 2 options that you have for printing variables. Very easy. Transforming the integer or the float or whatever variable you have to characters on the screen just happen. You do not need to do anything in particular. In C, C is different. In C, the instruction is printf. If you want to print a string, you just put the string in quotation marks, and that's it. But if you want to print a variable, like if you want to print the x, you cannot just put printf x. Why? Because the computer needs to know what do you want to print. The computer needs to know, you need to tell the computer what is that X. Oh, it's an integer variable. Tell me that it's an integer variable. Tell me that you do not want to print that integer value as a floating point number. Tell me that you do not want to print that integer variable as a character. Tell me what do you want to do with that integer variable. You need to tell me not only the name of the variable, not only one parameter, but always, always, always you need to tell me in a string, what is this? Okay. Options. This percentage D. D for decimal. Decimal mean integer. An integer in base 10. Printf, quotation marks, percentage D, closing quotation, comma X. That is telling the computer that I want to print X and I want to use the format on the screen as a decimal number. Okay. D for integers, decimal. F for floating point numbers. C for characters. And P for pointers. Those are my options. So what happens if I do a printf and I ask for a character and I use this variable X? X is a number. Can I ask this number to be printed as a character? Yes. What are you going to have on the screen is not the number, but the character that is equivalent to that number. The character. Java used the Unicode table to transform from values to characters. In C, you're going to use the ASCII code. So for instance, if you use 85, this instruction is going to print 85 on the screen. Two characters, the 8 and the 5. This one is going to print one character, 1. And that one is going to be a letter because 85 is equivalent to one letter in the alphabet, uppercase something. Instead of printing 85, it's going to print you the character that corresponds in the ASCII code to the 85. Now, no, do not use that one. This is a very tricky part, and I think I put a question in your exam about it. Percentage D is for integer values. You do not use percentage I. That do not exist. F works for floats and doubles. The character is easy one, and the one for pointers. So if you put another letter, you're going to get a compilation error. Your compiler is going to tell you, I do not understand what you want. D for integers. Even though it's decimal because base 10, not because decimals point something. For point something, floating point numbers is the F. Good. So this is a string alone. This is for a variable alone. If you want to put them together, you can have something like printf, and you can have an integer number here, and then you can have hello, and you can have a character here. The hello is going to be printed use normal. And in any place in which you put a percentage something, something else is going to be printed. For instance, I can put here, closing the quotation marks, I need another parameter, just like here, 2, and I can put x. But because I use percentage 2 times, I need 2 parameters. Could be the same variable, could be different variables, I don't know, whatever you want. Instead of the plus that you use here, and remember that you can use the plus several times, here we do not use the plus, here we use the percentage inside of the string, and then outside of the string, we need as many variables, doesn't matter that they are the same, that match each percentage. So when you print this, these are going to be matched in that order, and the result of this print is going to be something like, well, as a decimal, 85, and then you want hello, and then you want the same variable but as a character, whatever is the character. And this is what you're going to have on the screen. No quotation marks, just like Java. The quotation marks, this one, are not printed. Is the percentage that tell the computer the format, and then the variable as another parameter. And you can have as many as you want in one simple print. Good. So int total equal 100, and you can have something like printf your final grade is percentage D. And what is going to print that one? Your final grade is 100. This one is going to be replaced as a decimal with this value. Good. Going back to the example. This now hopefully is clear. Result and the column, the things in green are going to be printed. Result, even the spaces, and the column. Those is for printing. And then percentage F. Percentage F, floating point number. Which floating point number? Well, hopefully you remember this guy. Square root. In particular, square root of 2. This function in square root, you do not need the name of the class because we do not have classes. So it's not math.square root, it's just square root, SQRT. And that is a function that lives in this library. We need this library in order to use this function. And just like in Java, you can call a function inside another function. You can call a function as a parameter for other function. And whatever is the result here, you are going to print that using this format. And well, this is the result. Print as a floating point number, the square root of 2. Printing. Return 0, the program finished. That is your first program with C. Any question from the line 1 to 22? Nothing? Green? Red? Okay, hopefully fine. Important things. Now you know how to put comments in C. You know about the libraries. You know how to create functions, methods, and global and local variables. And hopefully you notice the similarities in syntactical, lexical, and semantical rules. These are the important ones, right? A second example, a new one. These are all the things that I mentioned before, so you have used the slides to review. The main is not any longer this long main. The percentage that you need to remember, the F, C, and the most important is going to be pointer, and in some point we need to review string. These two are going to be close related for later. And program in Java, program in C. Do you agree that those two are equivalents? If I give you in your exam this line and I ask you to write that line in C, can you give me this one? Or the opposite, if I give you the second one and I ask you to translate to Java, do you agree that the first one is the translation? Those are questions in your exam. Translate from Java to C or from C to Java. And this is our first example. Now, do you remember this thing here? The F at the end of the number? Why do I put in Java an F at the end of a number? And what happens if I just put 10.3? Which is the difference between this one and this one? Do you remember? Hopefully that silence is yes. You put the F at the end, thank you. The F at the end is a floating point number, a float. Without the F, it's a double. Do you remember that if you create this variable float, but you do not put the F, you receive an error in Java? Hopefully you remember that. Good news for C and C++. It doesn't matter if you have a double or a float. The computer, instead of expecting you to put here an F, the computer is going to read this. And if you have float, this is going to be 10.3 as a float. And if you put here double, this is going to be 10.3 as a double, period. The computer is going to read instead of asking you to put more letters. Good. And this is the way for you to printing things. Hello, the decimal number, by the floating point number, the integer and the float. And that one is the same that hello plus the x plus the y plus the y. Very good question. It's like, what is going to be printed? Good news in C and C++. You can tell the computer how many digits you want to print. So you can use %f, and with %f, usually it's going to print, like in my example. Did you notice how many decimals? 6, 7 is going to be usually what you're going to have, but you can put between the percentage and the f. How many digits do you want to have? How many digits before the dot and after the dot? Obviously, these ones are your decimals. And you can ask from 0 decimals, even though it's a floating point number, I do not want to print the decimals, I just want to print the integer part, which is okay. Or you can ask for 1 or 2, or well, you can ask for 10. If you ask for 10 and it's a floating point number, the computer is going to ignore you and it's going to print only 6 or 7. I mean, there is no way that you have more than 6 or 7 with a floating point number. And the same happens with the integer part. With the integer part, obviously, if you have a variable that is 100.3 and you ask here to print only 2 digits, the computer is going to ignore you because there is no way that I print in 2 digits at 100. This one is useful, like if I want to use 6 spaces, so it's like space, 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 and then 1, 0, 0 to create this idea of justification to the right. That is useful for that, but it's not going to print less numbers than the one that you have. And this is very useful for printing as many decimals as you want, like printing always 2, 3, or more. So, and yes, if you ask for 2, and you have this 3.351. What is going to happen is goodbye to the 1 because you're asking me for 2. So 3 and 2 positions, that is what is going to be printed. You have also in this library functions for etc. Mathematical functions if you want to do a specific rounding or whatever. But the other is used for the printing. How many spaces you want to print. That's it. Good. Now, one more thing in 1 minute. You know what? The ugly part here is this instruction. Everything is great, but the first thing that you are not going to like about C is the instruction that we use to read something from the keyboard. The instruction that we use to read something from the keyboard. The name of the instruction, scanf. Scanf, reading from the keyboard. Which are the parameters for scanf? Usually, you put there the variable in which you want to store something. Like usually, I will use scanf x because I have a variable int x, and basically what I want to do is to read something from the keyboard and store that something in the variable x. Usually, obviously, before reading something from the keyboard, you are going to ask the user using a print instruction like, hey user, I want something from you, right? Like, please give me an integer. But you are going to do that with a printf instruction. After that printf instruction, then you can use a scanf, and a scan basically is going to be waiting for the user to type something, and whatever the user type is going to be stored in this variable. So far, the mechanic looks like we do something similar in Java. The problem with C is two things. You want to store something in X? Number one, tell me in which format. Because, okay, you have this X variable, but you want to store something there. That something is going to be what? It's going to be an integer, it's going to be a character, even it's going to be a floating point number, it's going to be an address. What are you expecting from the user? Computer, I am expecting an integer value. Okay. An integer value. Scanf, two parameters. The first one is a percentage something. A percentage something. What are you going to read? D for an integer, F for a floating point number, S for a string, C for a char, and so on. Tell me what value are you expecting. Second, tell me the name of the variable in which you are going to store that something. Oops, a small problem. Usually, what you provide is the name of the variable in which you want to store something, like X. In C, what you need to tell the computer is not the name of the variable. You need to tell the computer the address of the variable. Yeah, the address. If your variable is in the memory and your variable is X, I don't care about the name X. What I want is tell me what is the address. So this variable, this space in the memory is the space F55. I mean, that is the number in the memory in which you have your variable, the name X. I don't care about it, but in this space is where you want to store the zeros and ones that correspond to whatever the user put in the keyboard. So if the user click the number 5 in the keyboard, you want to store here 1, 0, 1, just because that is 5 in binary. You need to tell me that you want to store that as a number, but you need to tell me also not the name, the address. And obviously, it's like, and how do I know the address? Easy. We have an operator that if you know the name, the operator go and ask for the address. And that operator is the ampersand. Ampersand and the name of a variable give you the address of the variable, the address in the memory. So when you use scanf, always, 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 you're going to have the format of what you want to read and the ampersand name of the variable, because this combination is giving you the address for the variable. And that's it. Homework for you. In a program, what do you think is going to happen if I have this variable x equal 10, and then I go and print f percentage p ampersand x? What is going to be printed with that instruction percentage p ampersand name of the variable? Any idea? You are correct. It's not going to be 10 because 10 is the value that is inside of the variable. The address of the variable, that is correct. Remember, ampersand, name of the variable, is going to give me the address, and percentage p is the format for printing the address. It's going to print something like whatever hexadecimal number represents the address of the memory. The most important thing that I want you to remember is C is going to give you access to know exactly in which position of the RAM your variables are. And we continue the next lecture. Thank you guys. See you.